Hi folks, Andy Fyon here from Rambles with Robin and Ruby. Join me in this video as I share what I see while walking over the rocky shore at the Schreiber Beach on the shore of Lake Superior. The Schreiber Beach is part of the longer and more challenging Casque Iles Trail system, which runs for about 53 kilometers or 33 miles from Rossport to the west to Terrace Bay on the east. Recall, my focus in summer 2025 was disjunct Arctic alpine plants located along the north shore of Lake Superior. In this video, I share what geological features I see on the rocky shore and some of the plants, including disjunct Arctic alpine plant species I recognized growing on that rocky shore. Join me as we enjoy the geology and associated wild plants along the north shore of Schreiber Beach, Ontario, Canada. Enjoy! So it's a beautiful Saturday, June 14, and we are headed down onto the Schreiber Beach. We're going to walk to the west end of the Schreiber Beach, where there is a rocky headland or rocky shore. And based on my looking at iNaturalist, there should be some Arctic disjunct plants there. So we'll have a look. It's although we're close to the shore, it's 12 degrees C this morning. The black flies arrived yesterday, and there are a few flying around this morning. I'm hoping that as we get close to the shore, the black flies will decide that there are better things in life than to torment a couple of senior citizens. So this part of the lakeshore is part of the Casque Iles Trail, which is over 27 kilometers from Rossport, apparently. Anyway, there's a fabulous trail system along the north shore of Lake Superior. And it goes by various names, but the prominent one is the Casque Iles. And there's Lake Superior, and it's one of its quieter, more gentle moments. And we are heading, oh my goodness, it looks like an all day hike to get to the rocky shore. Oh, about 100 steps and we'll be there. So at Schreiber Beach, we're on the rocky area to the west. And this rocky area with the red chairs is actually pillow basalt. And from a geological point of view, you can see the bun-shaped features preserved in the rock. Lighter green in the middle and a very thin, sort of 1 centimeter thick, dark green, rounded or edged to those bun-shaped features. This is basalt lava that was erupted and extruded on the ocean floor. And the bun-shaped features, geologists call those pillows. And they are an indication of subaqueous eruption of basalt. So here's a different point of view of the pillow lavas. This one you can see is quite dark in color, and that you're actually looking on the outer surface of the lava itself, of the lava tube. So pillows are tubes, and the melted basalt magma flows through those tubes. And remember that the selvage, the dark green edge between the pillows, has been quenched and cooled rapidly against the seawater, and that's why you have little gas bubbles trapped in the internal core of the tube itself. But this one is the actual outer surface, the way it's weathered and the way the ice has plucked the rock away. You're actually standing on the surface of what was a tube that was lying more or less horizontally on the ocean floor. And right beside it, you get back to the 3D cross-section where the pillow, like the loaf of bread, has been cut cut in half by the weathering. So you see the inside of the pillow. Here's another example over here where you see the inside of the pillow. That's a light green color. And this black colored material is the pillow salvage. So you know that the surface of the ocean was kind of inclined at 45 degrees to the horizontal. And perhaps it was inclined by great geological forces that tilted this whole rock package after it formed. Quite neat. More surface of lava tube here that you can see is nice and black. I can see right where my toe is. You can see little tiny holes in the edge of the basalt. So we have the interstice between pillows. We have the very dark green edge, which is the pillow selvage. And then you've got little holes or pencil-shaped voids. Those are vesicles. So that was gas that was trapped in the liquid basalt lava. And if you're clever, and I guess there have been some attempts to say, well, if you have gas, then this was erupted under a certain depth of water. Otherwise, if it's too deep, the gas would not have escaped from the liquid basalt. But it's a large outcrop of rock whose composition is dominated by iron, magnesium, calcium. And as such, under the right conditions, can give rise to a calcareous habitat. I wouldn't say here, but it's something to keep an eye out for. In terms of plants, we've seen Artemisia, ragwort, perhaps a balsam ragwort, is just starting to come into bud. We've seen the dregs of bird's eye primrose. The shrubby cinquefoil is just starting to come into bloom as well. And common butterwort is still in bloom. And I'm pausing here looking at this green thing because I need to look carefully at it. It turns out that this is another disjunct Arctic alpine species, having the common name of knotted pearlwort. It's a first for me. But this one is lovely because it's in flower. And there's a couple of others that are, there's a little mound of them again. And this one down here is also in flower, and a whole bunch of buds that are just about ready to come into bloom. So it's quite a neat little cluster of these little tiny flowering plants right on the, literally 3 meters away from Lake Superior. And I'm surprised to see them here because this is a wave-washed, ice-washed block of basalt. I'm surprised to see anything growing here. But here they are. There are other plant species that I saw, and I'll include some images of those plants. All of these were growing on the basalt rock substrate. We are at the famous red chairs here in Schreiber, at the Schreiber Beach, and behind us is Lake Superior, which you can plainly see, and the wind has just come up. So I think we're going to end up walking a little bit further.
Okay.
We've not been successful finding encrusted saxifrage yet. So that's it. Bye-bye.
Bye.
So we're just heading back to the sand beach, and we're going to have a look at the far end of the sand beach, which is still in the shade. but there's a rock cliff down there. We'll have a look at it. Actually, yeah, it's not really a sand beach, it's a pebble beach, that's right. So the next challenge is to get back across that creek. Time out. Lots of yellow tiger swallowtail. See 2, 4, 5 in there. Over here, 2, 4, 6, 8, 9. Extracting water and nutrients from this wet, silty material. Kind of cool to see the water from this creek discharge into Lake Superior. And I think the conclusion I've come to is I'm going to try and leap across that little water. No, I don't think I'm going to leap here. Could leap there. And I think what I might do is take my boots off, just in case. Now for a little more geology. What happens when natural chemical reactions transform the basalt rock into something completely different? The first chemical reaction type I saw creates a calcareous microhabitat by weathering of the basalt rock. Another geological observation here at Schreiber Beach. There's a lot of white, crusty material on the surface of this rock. And in my experience, that is typically lime, calcium carbonate, calcite in other words. The rock is breaking down, and as it breaks down, it releases calcium. And that calcium reacts with bicarbonate or carbonate ion in either the groundwater that is generated by the vegetation above us, the roots of the vegetation percolating down through cracks, or just by evaporation. The water is the groundwater in the rock, and there's lots of cracks and fractures in that rock that could carry groundwater. When it reaches the surface and exits onto the surface, the water evaporates. As it evaporates, it precipitates the calcium carbonate. In some areas, this can produce a microhabitat for calcareous plants, but I'm not seeing any plant here at all. Even the lichen doesn't like it by the looks of it. Coming down this little creek here, and you can see some white scale on this basalt rock, and that's a lime or calcium carbonate that's been weathered out of the rock itself. The rock's a little bit beat up here, which breaks down the minerals that contain calcium, and it's precipitated. There's quite a bit of it around. If we look over in here, all that white is the calcium carbonate. So it creates a little microhabitat that's calcareous. And we see common butterwort, shrubby cinquefoil, I see leaves of bird's eye primrose. So it's just a little tiny habitat, and it shows quite nicely how you can take a basalt or any rock and create an unusual habitat as that rock undergoes changes over geological time. Geological observation, creation of calcareous habitats by weathering of a rock whose primary minerals contain the element calcium. The second reaction type I saw was the weathering of naturally occurring iron sulfide minerals like the mineral pyrite to create a gossan or a rusty microhabitat. So a quick geological observation. I think much of this rock to my left is basalt, and in front of me there's a rusty area. This is not unusual. The color of the rust suggests to me that it's an iron sulfide that's in there. It could be pyrite, but it's not unusual in volcanic rocks to get concentrations of iron plus sulfur minerals, iron sulfide minerals. And when they're exposed to the water and the atmosphere, they weather and they turn into rust. That rust would be used as an indicator if you were a prospector of mineral in the area, potentially economic minerals. It would raise the eye of environmentalists, conservationists, because it can generate acid drainage. This is natural acid drainage. when the iron sulfide mineral rusts, it releases sulfuric acid. So it's a natural phenomenon, and it's an indication of the rock being almost contaminated, as it were, when the rock formed or shortly after it formed, by some sort of iron plus sulfur mineral, iron sulfide. We ended up looking at this cliff in front, and I cannot see any encrusted saxifrage on that cliff, although boy, it sure looked like a good habitat, a good environment for encrusted saxifrage. So I can't go much further along the coast. So just a view of where we have been. That's the sandy / cobble beach. Libby sitting there. And way down there, we walked a lot of that exposed rock, which is turns out is pillow basalt. And although we saw some interesting plants, we did not see any encrusted saxifrage. So that's going to be a wrap for Schreiber Beach. We will head on to a different location this afternoon. Neat stuff anyways, and it was a beautiful morning.